What if Flappy Bird and Breakout were merged into one game?
Imagine if Flappy Bird and Breaker were merged into one game. This was my idea for the Flappy Jam, a game jam where you had to make a video game in relation to Flappy Bird in 48 hours. Unfortunately, even though they added an additional 24 hours to finish the game, since I had just finished my game Radish Spike for the Roast Me Jam a week earlier, I was a little tired, so I didn't finish my game and ended up with this prototype. You play as, with bird controls, destroying blocks and avoiding bouncing off pipes. Even though I could not submit, I really liked this idea, so I decided to continue developing it for 1 week to see if it had potential. In this video, I'll show you how the bird works, how I made a modular pipe and block spawning system, which I think are really cool, and more stuff. Let's go. First, I'll explain how the bird movement works. Let's take a kinematic body 2D and add a collider and a Godot sprite as a placeholder. This is our bird for now. Let's apply a constant gravity downwards and an upwards force when the jump is pressed. We now have the base of our movement system, but here's where things get interesting. We apply a constant force right, making us go forward, but now get stuck on walls. To fix this, let's put a collider here, and when this collider touches walls, we'll multiply the bird's movement speed by -1, and this will make us change direction. However, this has some side effects. As you can see here, the bird is getting kidnapped by some pipes, and it's not changing direction even though it's touching a wall. This happens because the bird is actually colliding with two bodies in one frame. So it's flipping its direction twice, so it's not flipping at all. This is easily fixable by just allowing one flip per frame, but the thing is, this bug was actually a really cool feature because it allowed for the bird with precise jumping to not change direction when hitting two blocks at once, which was really satisfying to pull off. For now I fixed the bug altogether, but I think I will re-add the block breaking mechanic later on. There is also another problem. The bird just sticks to the ground when it's on it. We can easily fix that by adding a collider here that will make it so the bird will bounce off the floor when it touches it. Let's even add a collider on the top of the bird that detects ceilings and will apply a downward force when the bird touches one. But this system was flawed because when the bird was bouncing on the pipes, since the pipes were also moving upward, the pipes would catch up to the bird and the bird would do this weird shimmy thing. To fix this, I just doubled the force applied when the bird touches pipes. There we go, we now have basic movement. There are 3 things missing, however. Number 1, the bird should die when it touches pipes if I want it to function the same as the Flappy Bird. But the thing is, I actually kinda like it when the bird bounces off the pipe because it led to some nice strategy and interesting gameplay, so I'm keeping it for now.
Number 2. The bird's angle doesn't change whether it's going up or down.
Thankfully, a couple of months ago, I had just finished making multiplayer Flappy Bird on a calculator, video on that soon, so I had already tackled this problem, so it was very easy to code. So after some trial and error, the way I did this is to take the velocity.y value, that looks like this. As you can see, it's negative when the bird is going up and positive when the bird goes down. I essentially made a function that takes this value as a parameter and outputs the rotation for this value. So for example, if I take -100 velocity, that means the bird is going up, then it will return this angle on screen, which makes the bird's face up when it's going up, and this is what it looks like. I also added some interpolation because the rotation was a little too jarring at times. This is the final rotation. Number 3, the bird is not a bird, it's just, so I'm going to have to sadly get rid of my beloved Godot logo. For the bird sprite, I wanted to have this majestic white bird that can turn into a ball when it hits something and then turns back into a bird, mimicking both the bird from Flappy Bird and the ball from Brick Breaker, although the bird from Flappy Bird isn't exactly majestic. Here's my first attempt at pixel art for the bird, and it was not that great, a little too fat. And the second attempt was better, and I was too lazy to make a third one, and even though it's not my original vision, it's sort of grown on me, but I'm still thinking of it as a placeholder. To animate the bird, I just have 2 frames, one for falling and one for going up, and I just switch between these frames depending on the value of that velocity.y value from earlier. This has the really cool side effect of actually making the bird look like a real bird when it hops around the floor. I also separated the bird into parts and dyed those parts green when they touch the pipe, for example. This is just some visual feedback and it doesn't affect the gameplay whatsoever. If you're wondering where I'm at with the bird right now, I halved the bird sprite size because it was too high res in my opinion, the first version, and I added some nice post-processing to the entire scene.
In the actual Flappy Bird game, the way that the game works is that the player actually stands still, he's not moving, and a pipe object is spawned every now and then, with varying height every time, and the pipes are actually the thing that moves towards the player, giving the illusion of movement. But in my game, my player actually moves and the pipes come from the bottom, so this spawning technique doesn't work. During the jam, I just made this pipe object with one length and spotted it every now and then and moved it up, but this was boring and kind of rushed in my opinion. I wanted to make a modular pipe system that would spawn lots of different pipe combinations, so that's what I did. I started simple. I have 2 different objects.
A pipe object and an air object.
My pipe spawner chooses randomly between the 2. There is a 1 in 5 chance that the air object spawns and a 4 in 5 chance that the pipe object spawns. This was nice and added more variety, but it felt wrong having these floating pipe bits alone, so I coded up, in my opinion, the best system that I have ever programmed. I now have lots of other pipe objects, slabs, pipe ends, and more. My pipe spawner chooses one of these randomly to spawn. Let's say I choose the pipe object, it is now the chosen one. And no, this is not a joke, it's actually what it's called in my script.
The chosen one has a bunch of values, so I'll go over them one by one. First of all, the size. This is not the actual size of the object, like the scale, but it's actually how long we will wait until spawning the next tile. This makes it so if I have a slab, I can set the size to 0.5 and not have gaps like this. Then there's the rotation. The chosen one will spawn with this rotation. Thanks to this, I can reuse objects like the pipe ends by simply rotating them 180 degrees. And the next 3 values I'm about to tell you are the most important ones for this whole system to work. As you can see, I have a value that starts at 100%. Let's call it the likelihood for the pipe object to spawn. Before spawning the pipe, I get a random number between 1 and 100 and see if it is smaller or equal to my likelihood of 100. And if it is, I will spawn a pipe. Here we got 23, which is smaller than 100. When the system chooses the pipe object to spawn first, there is a 100% chance that the object that is going to be spawned is the chosen one, which makes sense. The pipe is therefore spawned and the rotation is applied. Then we wait the duration of time determined by the size of the object before deciding which blocks to spawn next. When the timer is over, we take that value of 100% and we subtract 20% from it. This 20% value I will call the likelihood decreaser. Our likelihood is now at 80%, so there is now an 80% chance of spawning the pipe object. When the spawner chooses the value between 1 and 100, we get 69, which is smaller than 80, so we're going to spawn another pipe object. We repeat this process until we get a bigger number than our likelihood. For example, here I got 44, which is bigger than 40. This means that we will not spawn our pipe object. Instead, we'll look at our last value of our pipe, which is a list of all the things that can spawn after a pipe object. As we can see, the only thing that can spawn seems to be a pipe end facing up, so it becomes the chosen one. The pipe end facing up has a likelihood of 100% and a likelihood decreaser of 100% as well. It will only spawn once, since when it is chosen it has a 100% chance of spawning, and after it is spawned and we subtract 100 from 100, the pipe end now has a 0% chance of being spawned. Here's an example of the system working in-game with the values changing accordingly. So yeah, that's my pipe spawning system. Now I'm going to talk about the most important part of this game, arguably, the blocks. As you might have guessed, right now the objective for the game is to break all of the blocks. There are two types of blocks for now, the regular blocks that change your direction and the pass-through blocks. The block spawning system is a lot simpler than the pipe spawning system. I just have a bunch of these block chunks that I put into a list and then the spawner will spawn them in random order. This means that, like the pipes, I can actually have more than one spawner in the game scene. So that's all that I did in that 1 week of development. In the next devlog, I'm going to cover those wiggly pipes you saw at the beginning, as well as the new blocks. If you have any ideas, suggestions, or just comments in general, leave them in the comments because I read every single one. Thanks for watching, and see you next time.